Hello everybody and welcome back, and in this tutorial let us see an idea behind the actual SYN flood attack. Now the SYN flood attack is basically just sending the TCP packets to the target, spamming it with a bunch of packets, and then basically making an over connection to each port and make the target not being able to actually run any software on open ports or connect to the internet as well. So let's see how we can do that. What basically SYN flood is, as I said, we will just be sending a bunch of TCP packets to the target. Now this will not be enough to actually crash the target since you're sending this from one PC, but if you, for example, have a botnet, which we'll see in the future lectures how we can actually create a command and control center with the multiple PCs connecting back to us, and then you can upload the software to each one of them and run the actual attack. But for now on, let us see the simple code behind it. So first of all, what we can do is first of all open Scapy. And what we can do with Scapy is actually see what the actual power of Scapy is. So let us create a simple packet. So the packet will actually have two layers. One will be the IP layer. So let us select the IP layer to equal the IP packet. For now on, we will not select any options. All we want to do is just print the IP layer. Or not like that. We want to actually add .show in order to see the fields of the IP layer. So with the IP layer, what we will do is we will actually concat the TCP packet to this IP packet. So we also want to add the TCP layer equals TCP. We open and close the actual brackets. We don't specify anything. And in order to put these two packets into one packet, we need to make, for example, a packet variable, and that packet variable will be equal to IP layer / TCP layer. And then if you just print packet.show, we can see all the fields from our packet. So in order to actually send this to someone, you can see a few fields that we actually need to change. That would be the source field and the destination field. Now the good thing about this is that the source field, which will be our IP address of course, and the destination field, which will be the target's IP address, don't even have to be true. Now the destination IP address has to be true in order for this packet to go to the right destination, but the source field, we can select our IP address to be anything we want, and target, while scanning it with Wireshark, will see a fake IP address. So let's see how we can do that. First of all, let me run Wireshark from my Windows 10 PC, which we will be attacking. So if I run Wireshark right here, basically Wireshark is a program for sniffing packets. We can not intercept, we can actually view the packets and their fields in the Wireshark as they flow on our network interface. So let me just show you. First of all, let's wait for the Wireshark to actually open. And then what we will do is we will send this packet with, first of all, the true source and the destination IP. And then we will try to fake the source IP and see if our Windows 10 machine will see the IP address of our Kali Linux machine, or will it see the IP address that we actually faked. So our Wireshark is opened. If you don't have Wireshark, don't worry, it is basically pre-installed in Kali Linux. You can just type Wireshark in terminal and this will open. You don't need to run it in Windows 10. But in case you are running it in Kali Linux, you need to specify the target to be your Kali Linux machine, which you can easily specify just by selecting the source and the target to be the same IP address. So you're basically sending packets from you to yourself, in case you don't have the Wireshark on any other PC. Or if you want to actually do the same attack right here, you can just download Wireshark. It is not really that hard. And then you can perform this and inspect the packets that we're going to send. So let's wait for this to load. It is a little bit slow because I'm running a bunch of things such as the actual virtual machine. And while it's actually opening, what we can do is select the source field and the destination field. So the packet.source field we can select to be the IP address of our Kali Linux machine, which is 192.168.1.7, and the packet packet.destination field can be equal to the IP address of our Windows 10 machine, since we are attacking Windows 10, so 168.1.5. And if we inspect our packet once again in order to see if the actual things that we specified are correctly specified, so they are right here. Let me just see if this is opened. Okay, so we got some window prompted. Let me see what this window is. It is some update. We don't need an update right now, but it doesn't want to close, doesn't even matter. And you select the interface that you are sniffing packets on, which in my case will be the Ethernet interface. In order to only filter out some of the packets, you can just type right here TCP packets, for example. Or it is lowercase TCP. You press the blue arrow right here, and right now you will be seeing only the TCP packets. So let's see what happens once we actually send this packet. So in order to send the packet, we can just use the send, and in the brackets we specify what we want to send. We are sending the actual packet. If we go back right here, we stop this, and right now what we want to do is actually try to find our packet that we sent. So if we find it right here, you are looking at the source and the destination. Remember that the source we specified to be the Kali Linux machine, and the destination is the IP address of this Windows 10 machine, which is running the Wireshark. And we can see that our received the packet from the Kali Linux machine, which is 192.168.1.7, and we can see that the actual source field is the good IP address. So this is the packet that we send with our SCPA. So there are a few things that you can actually modify into sending malware packets or so on and so on. As you can see right here, if I go back to my packet and I add a load to be equal, or I'm not sure if I need to specify brackets, to be equal to hello string, or maybe it is packet.raw.load. Not really sure. Let me just remember what the actual syntax is for this. So let's see, packet.show. Okay, so yeah, we need to add another layer, which will be the raw layer, I believe. So packet will equal, or another packet, so packet2 can equal raw. Good, so, and all we have to do is make our packet to be equal to the previous packet and then slash packet2. So right now what we have is also a raw layer. If I just print it like this, so packet.show, you can see we have a raw layer that is concatenated to the TCP packet, which is concatenated to the IP packet. And what we can specify in the raw layer is this load field. And in order to do that, we can just type packet.load equals, between the double quotes, hello, this is a secret message. We close the double quotes and we send the packet once again. But before we send the packet, we need to start actually scanning for the packets once again. We do not want to save this. We only filter the TCP packets and we send this packet. We sent one packet, so we can now stop this. We want to find the actual IP address of our Kali Linux machine, so it is .1.7. Let us try to find it. It is not here. Let's go a little bit up. Okay, so here it is. This is the packet that we sent. If I go right here and you go to the transmission control protocol, let me just go right here. You go to the TCP payload, click on that. You can see the TCP payload is 30 bytes. And you can see that we actually send, hello, this is a secret message to our Windows 10 PC. We actually send some data to our Windows 10 PC with our SCPA library. Now let's see how we can actually fake the actual IP address of our Kali Linux machine. So we can do that just by changing this source field right here. So if I just type packet.source equals, for example, let's use the Google IP address, which is 8888. We send that, we start intercepting for packets in our Wireshark, continue without saving, we only scan for TCP packets, we go back here and we send the packet. We go back right here, we close this, and we can see our packet is right here. And in the Windows 10, it pretends that it is a Google server, which it really isn't. We just changed our packet source IP address to be the 8.8.8.8, and it still has the hello, this is a secret message that we encoded into our TCP payload. And as we can see, the Windows 10 has no other way into actually finding out who actually sent this packet. As we can see, all the other fields, the actual Internet Protocol field, let us find it right here, since there should be the source IP address, and we can see that under source IP address is the actual 8.8.8.8. So it really does seem that this packet came from the Google DNS servers, which it really didn't. Now, in order to create the SYN flood, which I talked about, all you have to do is create a packet. So let us go to our Python programs, go to our local network programs, and nano syn flood.py. And there all you have to do is add this line user bin python from skp.all import all. You can just import, or pardon me, not all, we want to import. We can actually import everything with this star right here, so hopefully something like this will work. We can check it out. And all you have to do right here is actually make a SYN flood in order to, or basically create a packet and run it with a while loop or while true loop, and it will send the packets forever to each port. Now we will be doing that in the next lecture, so we don't make this one too long. So I hope I see you in the next lecture where we will actually code a SYN flood program. It is rather short, so don't worry. I hope I see you there, and take care. Bye.